chemical equations, remember, are like the recipe for an experiment. The recipe for a chemical reaction to take place is written as a chemical equation. And we talked about different types of chemical equations. Remember, we talked about single displacement, double displacement, synthesis, composition, and what's the last one? Combustion. Yep, combustion. And did I say decomposition?
Nope.
Okay, so there we go. There we got 5 of them. Very good. So 5 types of chemical reactions and chemical equations. And so today we're going to talk about how a chemical equation has to be written. And it has to be what's called balanced. What do you think balanced means? Equal, good. The same on both sides. And so when we say we have to write a balanced equation, it means that we're going to balance our equation to satisfy the law of conservation of mass. Now, do you remember the tagline for the law of conservation of mass?
Mass is neither created or destroyed.
Good. Mass is neither created or destroyed. And so what that means is that what you put in to a chemical reaction, you have to get out. Okay, and so a chemical equation is all about finding out what is the ratio of our reactants that we need to put in comparison to our products, and how many hydrogen atoms do we need to put in to be able to get out the right number of hydrogen atoms, and blah, 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 okay? But whatever you put in, you're going to get out. And so when we balance equations, we're going to balance each atom one at a time. And I'll show you kind of the process that I use to balance equations. But the thing you need to remember is that when we balance chemical equations, it might take more than one try, okay? You might have to go back and forth to be able to get your final answer, but there's only one right answer, and you're always going to be able to check your answers. So there's really no reason that we should get a balancing equation questions wrong, because it's really all just about counting, right? Can we count, did 4 hydrogen atoms go in? And if so, did 4 hydrogen atoms come out, right? Those are the types of questions we're going to answer. So it might take multiple tries to get to our final answer, but you can get there. Okay, it's a kind of a puzzle, so we got to go back and forth. So let's look at a real quick example here. We've got a reaction that says H2 plus Cl2 yields HCl. And this is an unbalanced reaction. Okay, it's unbalanced. Do you know why it's unbalanced? Yeah, what do you think?
We put in 2 H's and we put in 2 Cl's and we only got 1.
That's right. We put in 2 hydrogens and 2 chlorines, but look, how many of each of those did we get out?
4. Wait.
Of each, how many hydrogens are on the right side of my equation?
1.
Only 1, right? But I put in 2. So there's no way a hydrogen would have disappeared somewhere, right? This is an unbalanced chemical reaction. We wrote out all the reactants and all the products, but our ratio is not right yet. Okay? So can you think about a way, how could I fix this to make it balanced? Yeah, what do you think?
Put a 2 on the H2.
I add a 2 right there. Do you remember what that number that comes in front of my reaction is called? A coefficient, just like it is in math, right? If we have 2x, this number is called a coefficient. And so the same thing happens here. The coefficient we apply in the front here applies to both hydrogen and chlorine. So, okay, so now I see that we've got 2 hydrogens and 2 chlorines on the right-hand side. Do you see how that makes it balanced? Mm-hmm. Okay, I need like a nod yes or no, right? We've got 2 hydrogens, 2 chlorines, and then 2 chlorines, right? I can't really draw that one, but okay. All right, so then I just drew it out as a balanced reaction now, which is fine. Okay, you see how in our products side, they rearranged, right? When they went in, the hydrogens were paired with each other. But on the product side, the hydrogens are not paired with each other anymore. They're bonded each with a chlorine. Do you see how that works? Right? This is the reactants side. This is the product side. So when they went into the reaction, it was H2 and Cl2. They were bonded to each other. And then once they came out, hydrogen was bonded to chlorine and hydrogen was bonded to chlorine. That's what happens in a chemical reaction, right? Something new is formed. So we took a hydrogen molecule and a chlorine molecule, separated them, and then they found a new partner. Okay? What type of reaction would this be called? Synthesis. Very good. We started with two smaller things and came up with one big compound. Okay, a synthesis reaction. Very good. Okay, so a couple things that we need to remember as we balance equations, okay? Things to remember. We'd never add coefficients in the middle of a chemical formula. We never add coefficients in the middle. So let's say if our last one looked like this, we had HCl. We needed 2 chlorines. Let's say we just needed to have 2 chlorines. I can't do this. Put a 2 in the middle there, right? That's no good. Okay, I can't add a 2 in the middle. I also cannot add a subscript. Okay, I can't change the formula. So I never change subscripts in a correct chemical formula. So if my formula is HCl, and like I said, I needed 2 chlorines, I can't just do this and make it HCl2. That doesn't work, right? The only place that I can add something is in the front. And so now that changes both my hydrogens and my chlorines. Okay? We write out our final formula. If it's possible, you can reduce your coefficients. So if you accidentally kind of overshot it and your coefficients are all reducible by the same number, you can reduce them down. That's not something I want to spend a whole lot of time on because it doesn't happen that often, but it could. Okay, so if your coefficients, right, coefficients come in the front, if they're all reducible by the same number, we can reduce those down. Okay, let's go ahead and try a practice one here. Okay. Balance this equation. Okay. Is that different than the one that's on your sheet?
No.
Is it the same? Okay.
Put it all together.
Nope, we're not going to put it all together. We're going to list what we have. Okay, actually, I'm going to change one thing here. Okay, just cross out the one that's on your sheet. I'm going to give us a little bit of a different one. Okay, Cu plus Ag3N yields Cu 3N plus Ag. Okay, I'm going to change that formula just a little bit because we didn't deal with anything with those NO3s yet, so I'm going to take those out. Okay, so let's use this practice now. Can anyone tell me what type of reaction this is?
Combustion.
No, not a combustion because combustion has to have carbon dioxide and water as our products. It's a single displacement. It is a single displacement because I have something that's by itself and it's taking the place of silver, right? We're having one thing that's swapping, so it's a single displacement. Okay, so now here's how I go about balancing my reactions, okay? I'm going to make a list of all the elements that I have. I have copper, Ag is silver, and I have nitrogen. I'm going to make a list right down the middle. And then I'm going to give myself room to work on both sides. Okay, so I'm going to give myself some room to work on both sides. So this is just like a workspace I'm using, okay? And the very first thing I'm going to do is I'm going to count how many of each atom do I have, okay? This on the left side is everything that happens to the left of the arrow, and on my right side here is everything that happens to the right of the arrow, right? So I'm really processing what goes in and what comes out. So let's count. How many coppers are on the left side of my equation? 1, right? Because I assume there's a 1 right there. So how many silvers are on the left side of my equation? 3, right here, right? That 3 tells me that I have 3 silvers. And how many nitrogens are on the left side of my equation? 1. Okay. Now I'm going to count the right side. Okay, are we doing okay so far? On the right side of my equation, how many coppers do I have? 3. How many silvers do I have? 1. And how many nitrogens do I have? 1. Okay, so now I'm going to check if my law of conservation of mass was satisfied and if my equation was balanced. These lists would match, right? The coppers on the left and on the right would match. The silver on the left and on the right would match. The nitrogens. Everything would match left and right. Okay, but right now that's not the case because it's saying that I'm putting in 1 copper, but yet after my reaction I have 3 coppers. That's not possible, right? Copper can't come from nowhere. So I need to balance my equation. Okay, and the way I do that is I go check my list here, right? This is my list, and say which of my elements is not balanced yet, right? And by balanced, I mean the same on both sides. So which of my elements is not balanced? Copper and silver. That's right. So I'm just going to pick which one to start with. And I'm just going to start with copper. I need to have 3 coppers on the left side of my reaction to match the right side of my reaction. So what can I do to copper on the left to make it a 3?
3 coefficients.
Okay, right. Can I do this? Can I just say it's CU3?
No.
No, I have to add it in the front, right? The only place I can add it is in the front. And I'm not going to put a 2 there because that would just count 2, right? This tells me that I have 3 coppers. So after I change that coefficient, I'm going to come recount it and change it in my list as well, right? I'm going to reflect that change in my list and say I don't have 1 anymore. I've got 3 coppers on the left. Does that kind of make sense? So now my copper is balanced, my nitrogen is balanced, but my silver is not. So can you see what I'm going to have to do with my AG?
Make it a 3.
On the right-hand side, what am I going to do? I'm going to make that a 3, and then I'll recount and say, okay, on the right, I have 3 silvers, which means that now this is a fully balanced chemical reaction, right? I put in 3 coppers, 1 compound of silver nitride, and from that, I get 1 compound of copper nitride and 3 silver atoms.
So all you're doing is putting the number that you got in the first part, and then putting it.
Yep, we're just counting them and adding a coefficient so that our elements are equal on each side. Now, let me make this clear. Copper does not need to match with nitrogen, right? Copper just needs to balance copper. Silver just needs to balance silver, and nitrogen has to balance nitrogen. So they don't all need to match each other. They need to match themselves on the left and on the right. Okay? Tell me, what questions do we have so far? Okay. All right, we're going to make our list. First, right here, I've got A, L, and B, R. Okay, and I give myself some room to count those elements. Am I going too fast, or are you hanging in there?
I don't know.
Okay, how many aluminums are on the left-hand side of my equation? 1. And how many bromine? 2. On the right-hand side, how many aluminums? 2, right there. And how many bromines? 6. Okay, so none of my elements are balanced yet, right? So I look at my list and I just ask myself, what's the easiest change I can make? And both of these changes are pretty easy, right? To go from 1 to 2 on aluminum, what should I do on the left-hand side? Right here, I'm going to make, this is originally a 1, right? If there's nothing there, we assume it's a 1, so I'm going to make that a 2. After I write that coefficient, I need to reflect that change in my list. So I recount and say, I don't have 1 aluminum anymore, I have 2. I want to make it really clear that I don't want you to try to change your list, then change your coefficient. You should change your coefficient and then let it trickle down into your list. Okay? Because if you try to start crossing things out and balancing things before you do anything in the equation, it's just going to confuse you. Okay? So next thing I look, right, aluminum is balanced, but bromine is not. So what can I do to get bromine balanced?
Make it a 6.
Am I going to put a 6 right there? No, because I need to put a 3. I want a total of 6 atoms. And since there's 2 of them there, 2 times 3 gives me 6. So that's how I'm going to figure out what I need there, right? I've got 2 bromine atoms. And to get to 6 in total, I need to take 3 of those molecules. So now that's my final balanced reaction. Okay?
So how the subscript you multiply it, and that's what you get.
Yep. Try this second one on your own. Is that what we had?
Well,
I have 2, 1, 2.
I did not get that.
Okay, let's walk through it. If I do my count, I've got K and I've got Br. So I've got 1 potassium and 2 bromines and 1 on the right side. So the only and obvious change I need to make is that I need 2 bromines over here, right? But if I add a 2, that not only changes my number of bromines to 2, but what does it also change? It also changes my potassiums to 2. And so now I've got to see, okay, my potassiums are not balanced anymore, which means I need this to become a 2, right? So I have to add that one on the left. Because I put a coefficient in front of a full compound, it doesn't only change bromine, it changes potassium as well. And so now once that becomes unbalanced, I have to make a change to potassium. So it should be 2, 1, 2. Okay, is that making sense? If it changes more than one atom, you've got to come down and make those changes on your list to get it rebalanced. Okay, let's try the last one together here. We've got 3 different elements: sodium, hydrogen, and oxygen. Okay, remember I said that sometimes balancing equations take some back and forth, right? You're going to have to maybe bounce back and forth. You might not get it exactly the first try, okay? So let's count these ones. On the left, how many sodiums do I have? 1. How many hydrogens? 2. And how many oxygens? 1, right? 2 hydrogens, but only 1 oxygen. On the right-hand side, how many sodiums? 1. How many hydrogens? 3. See, I've got 1 here plus those 2, right? That gives me a total of 3. And then how many oxygens? 1. Okay, so we've got a little bit of an issue here, right? Because hydrogen is the only atom that's not balanced right now. But you see how it's kind of tricky because this is an odd number of hydrogens? Am I ever going to have an odd number of hydrogens on the left-hand side? No, it doesn't matter what coefficient I put here, 2 or a 3 or a 4, whatever I have, I'm always going to have an even number of hydrogens. Do we agree with that? So I've got to find something here to get my hydrogen number to even. So I'm going to start with an even coefficient right there, right? And I'm just going to start with a 2. Not only does that change my sodiums, it also changes my oxygens and it changes my hydrogens to what? 4. 2 right here, 1, 2, plus these 2 is 3, 4. Okay. All right. So I've got a total now of 4 hydrogens on the right-hand side. So now I'm in a place where nothing is balanced, right? But I know I'm moving in the right track because I've got my hydrogens even at least. So now I'm going to flip-flop to the other side, and it doesn't really matter which one I change next. I'm just going to start with putting, what number should I put right here?
2.
If I put a 2 there, that changes my hydrogens to what? 4. And what does it change my oxygens to? 2. Okay, so now it looks like my hydrogens and my oxygens are balanced. What needs to happen to my sodium over here?
2.
It needs to become 2, and that changes my list to 2. And so that means I've got a balanced equation, right? Uh-huh.
So on the right side,
Mhm.
this is like, just kind of zoned out for a second. I need you to reiterate.
Okay.
Like, if there was nothing there, how did we get the 2?
This one
Yeah, no, the other.
right here.
Yeah.
So I chose to put a 2 there first because I started out with 3 hydrogens. 1, 2, and 3 hydrogens. But on my right side, there was no way I was ever going to get 3 hydrogens because no matter what coefficient I put there, it would have been an even number, right? 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, right? I would have never had an odd number. So the way I started this is I wanted an even number of hydrogens on the right-hand side. So I put a 2 there, so I would get 2 hydrogens plus 2 more, which is 4. That's how I started that because I wanted to get to an even number of hydrogens. Okay? Then I just bounced to the other side from there. Right? I looked at my list and see what needs to be fixed. Okay, balancing reactions is really a back and forth type thing, right? Pick a starting place and it might bounce you to the reactant side, into the product side, or whatever it is. There's lots of different ways you can get to your final answer. You don't have to follow the same path that I did. But the important part is that there is only one right answer. You can always check yourself. Okay, there's only one way to do it. All right, let's try a few more here because I think we need a little bit more practice. Okay, let's do the first one together. You want to make your list to start. So I've got lithium, chloride, sodium, and sulfur. I've got 4 different elements present. What type of reaction is this? Double displacement, right? The outsides are going to end up coming together, Li and S, and the insides are going to be able to come together, Na and Cl, right? They both get new partners. That's double displacement. All right, now let's count. Okay, on the left side, how many lithiums? 1. How many chlorines?
1.
Sodium? 2. And sulfur is 1. All right, on the right-hand side, how many lithiums? 2. Chlorines? 1. And sodiums? 1. And sulfur? I think just 1, right? Because there's no coefficient or there's no subscript right there, so just 1. So I'm just going to look at my list now and say, where's an easy change that I can make? Okay, I'm going to start up here at the top with lithium, just because. Okay, so it's easier for me to change 1 lithium to 2. How do I do that?
2.
I put a 2 there. But it not only changes lithium to how many?
2.
It changes it to 2, but what element does it also change? It changes chlorine to how many? 2, right? There was 1 to begin with. Now there's a coefficient. So 1 times 2 is 2. So now I'm going to look at my list again and say, okay, I'm going to bounce back over, right? It changed chlorine to needing 2. So I'm going to come over here and say, how do I make this chlorine? How do I get that to a 2?
2.
Okay. And so that changes chlorine to 2, but what does it also change? Sodium to 2. All right, and so there we go. I look through my list, balance, 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 and so that means that is a balanced chemical reaction. Anything I need to do if it's already balanced?
No.
I just leave it. Okay, so I don't have to do anything. Okay, well, there you go. I guess let's try the second one. You want to try the second one on your own?
Sure.
Try this one on your own. If you get stuck or you have questions, raise your hand and I'll come around and answer those. Tell me what type of reaction that is. Oh, wait, I'm missing something. Sorry, I'm missing something. This is CaO. I apologize. That's CaO, not Ca2. CaO plus Li3P yields Ca3P2 and Li2O. So it has to be double displacement, right? They are both getting new partners. Calcium is going to bond with phosphorus, which it does, and lithium is going to bond with oxide, which it does. Okay, so it's a double displacement. All right, so I'm going to make my list here of all my elements, right? I assume that they all start out with a 1 in front of them. I'm not going to write that, but I assume that there's a 1 in front of all of them. So I've got calcium, oxygen, lithium, and phosphorus. I want everybody to be on the same page counting here, so I'm going to go slow. Okay, I want everyone to have their list written out before I even start counting. So are we on that? Are we to that point yet? Do we have our list written out and our reaction written out? Okay, let's count on the left-hand side. All we're starting with is the left. So how many calciums? And I want everyone to say them. I want you to be confident about how many there are. So how many? 1. How many oxygens? 1. How many lithium? 3. And how many phosphorus? 1. Okay, good. Are we on the same page with the counting part of it?
Yeah.
All right, now let's flip to the other side. Calciums, I have 3. Oxygens, I have 1. Lithium, I have 2. And phosphorus, I have 2. Okay, so I'm going to look at my list. There's 2 changes that I think would be considered easy to make, and you could start at either place. This could be an easy change, or this could be an easy change. Would we agree? Yeah. This one is not an easy change. right? You know what I'm saying? That one's not an easy change because going from 2 to 3 is just, it doesn't work, right? I can't add a coefficient and automatically get there. So that's no good. And then this one is already balanced, so I can't start there. So I'm just going to pick one, and I'm going to start with calcium. Do I need to make a change to calcium on the right side or the left side? The left, right? Because I have more calciums on the right than on the left. So what could I put in front of calcium to make it balanced?
3.
What coefficient has to go there? I need to have 3 total calciums. Right now I only have 1. It has to be a 3. I don't add to it. I assume if that's a 1 right there, I've got to have 3 of those compounds. So I'm going to go put a 3 there. Are we clear on why I decided to do that? I need 3 calcium atoms. Right now I only have 1 of them, right? Because we assume there is a 1 right there. So I'm going to take that out and I'm going to put a 3. Then I come recount. So I don't have 1 calcium atom anymore. I have 3. What other element did adding this 3 affect? It affected oxygen as well. So how many oxygen atoms do I have on the left-hand side now? 3, right? Because this is a 1. 3 times 1 is 3.
So would we also have to change the other side?
We will eventually have to change the other side. Good. Okay, so that's where you choose now. I like to kind of bounce back and forth like that, right? This change altered my oxygens. So now I'm going to come check the right side of oxygen and say, is it balanced or is it not? And it's not, right? So now I'm going to figure out what can I do on the right-hand side to make 3 oxygens. What do I need to put there in front of it to get to 3 oxygens?
3.
It has to be a 3, right? Because there is a 1 hidden there. So 3 times 1 is, how many oxygens is 3? What other element did it affect? Li, or lithium. And so how many total lithiums are there now? 6. 2 times 3 is 6. Okay, so now I'm going to go back, jump back over. I just changed my lithiums now. So now I'm going to come check my list for lithium and say, they're not balanced yet. I'm at 6 and 3. So what do I need to do to get that to a 6? 2. So I need to put a 2 there. That changes my lithium to 6. But what other element does it change? Phosphorus to a 2. And so then I come check over here. Is that balanced already? Yes. And so then I am done. Okay, do you see how it bounces you back from one side to the next? That's going to be my recommendation, is that I changed calcium here, which caused my oxygen to change, which caused my lithium to change, right? That's where I'm going to see you bounce back and forth from reactant side to product side.